Hello to every grade 11 out there. Welcome to Crazy Physics Maths. And in this particular series of videos, we will be looking at everything geometry. And everything geometry, we will be looking at Euclidean geometry in our part 1. In our part 2, everything geometry, we will be looking at analytical geometry. So it's everything geometry. Part 1 is Euclidean geometry. All right, Euclidean geometry is quite a very, very interesting aspect of maths because it really engages you to think, to find things. So I will be taking you through, but I will be taking you through unconventionally as it is in your textbook. I will not be using the arrangement in your textbook. So please follow through. I will deal with this Euclidean geometry in different parts, in different series of the video. So please make sure you get all. This is lesson number 1. And I will be using an acronym. All right. Thanks, doctors in Cape Town +1. Thanks, or we can say thanks to the doctors in Cape Town +1. Thanks, doctors in Cape Town +1. And if we were to spell it out, we would say TX, thanks. Doctors, DRS, Cape Town, CPT, +1. You will understand what this is all about in just a moment. So, this is going to be my order of looking at Euclidean geometry, as opposed to the arrangement, the conventional arrangement in your textbook, Theorem 1, 2, 3, and 4, and up to 11. So, let's get into this quickly. So we look at every letter here, and every letter carries a whole concept. Let's start with T. T tells me about triangles. There are certain things I need to know about triangles. I will not be discussing everything about triangles. I will only discuss the quick things that we need to know here when it comes to a triangle. And the first basic knowledge is the interior angles of a triangle. Sum of interior angles of a triangle. And we know that that is equal to 180 degrees. That is, if I were to add all the angles, the interior in this triangle, I will be having 180. So let's call this A, let's call this B, let's call this C, and let's call this line D. So basically we're saying angle A plus angle B plus angle C should be equal to 180 degrees. That is very, very key. Okay, I'm going to call this 1 and 2. That is very, very key. Basic. Number 2. Now, if you look at BCD, line BCD is an extended line. Extended line. Please, when we say the line is extended, it must be a straight line. So the section CD is an extension of BC. I want to say that again. The section CD is an extension of BC. So we take BC and we continue. Please, if I were to draw the line like this, then it is not an extended line. All right. If it's an extended line, please take note, it must form an angle of 180 degrees. So I'd like us to quickly put some notes down on that extended line. Then we look at what we're trying to prove. Extended line. Okay? It is an extension of one of the sides. It is an extension of one of the sides. It forms an angle, or let's say it maintains rather. it maintains an angle of 180 degrees, of 180 degrees with the shape. All right, with the side of the shape, because I want to use the side of the shape because I'm going to need this story of extended line later on. All right, such that C1, angle C1 plus angle C2 is equal to 180 degrees. Now, once we have that extension and we understand what an extended line is, we can then talk about the exterior. So C2, angle C2 becomes the exterior angle of the triangle ABC. Now, where are we going quickly with this? We are then going to conclude, this is our conclusion. Angle C2 will be the sum of angle A plus angle B. And what is our reason? Exterior angle, we can write it like that, all right, of a triangle. We don't have to write it in full. Exterior angle, all right, of a triangle. Sum of exterior angle of a triangle. Please, as we go through, I am going to be very, very specific about how to write our reasons. There are correct reasons that we need to write. If we don't write the correct reasons, we will be marked wrong in an exam. So please, I'd like you to follow through. So when we come to the exterior angle of a triangle, all right, that's how we write our reason. And basically, this is what we're saying. I want to write the whole thing in full, the whole theorem for you in full. We're saying the exterior angle, or let me write it on the other side of the page. So we're saying that the exterior angle of a triangle, I'm just going to use the shape here, all right, is equal to the sum of the interior opposite angles. You don't have to write all of this. We just write the short form, exterior angle of a triangle. And I'd like us to check how that came to be. Watch this quickly. This is now extending or expanding your knowledge and making it sufficient for you. A plus B plus C1 is equal to 180 degrees, right? From the first thing we said, sum of angles in a triangle. But C1 plus C2 equals to 180 angles on a straight line. So what is C1? C1 is 180 minus C2. If I then take that C1 and throw it in that equation, angle A plus angle B, now instead of writing C1, I would write 180 minus C2 equals to 180 degrees, right? So we throw it back in the first equation there. Now you would notice if I then move everything over, angle A plus angle B will be, the C2 is negative, when I move it over it becomes positive, all right, plus 180 degrees. Now I'm taking the 180 degrees over. Oops, what do you see there? Do you see that my 180 then cancels each other? So A plus B equals to C, angle C2. The exterior angle of a triangle is equal to the sum of the opposite interior angles. But But please make sure that you see it as extended line. You cannot have an exterior angle if you don't have an extended line. How do you identify the extended line? It must be a continuation. The line is extended and it must form an angle of 180 degrees with the shape. All right, one more slide about triangles and then we will move on. So we are still on T. We are still on T. Quickly. Types of triangle. Types of triangles. We need this information. Okay. Number one, a rat. You know what I mean when I say a rat? A right-angled triangle. Right-angled triangle. So we're just looking at basic things that we're going to need. Okay, that is 90 degrees. And if I call this A and call this B and call this C, or whichever way we want to label it, doesn't really matter. Then this one becomes a small b because it's the opposite side. C, facing angle C and A. What do we know? If I call this theta and call this alpha. Okay, sum of angles in a triangle, we know that already. Alpha plus, so we can say theta plus alpha, therefore, will be equal to 90 degrees. Why? We already have angle B as 90. It means the sum of the other two will be 90. That's the first point. Second point is to remember that I have to use Pythagoras here every time I have a right angle triangle, and it's the hypotenuse squared. This time around it's our B. A squared plus C squared. Please take note of that. This is, in this case, the hypotenuse is equal to the sum of the square of the other two sides. Other two sides. Sweet. We're going to need this as we go on in Euclidean geometry. The second type of triangle that I'm going to need us to quickly look at for this particular. So when I say types of triangle, we're looking at things that will help us in our journey of Euclidean. Number two is an isosceles triangle. Iso, the word iso means that things that are same. So I would have two sides equal. A, B, and C. Okay? So two sides equal. Side AB will be equal to side AC. That's what makes it an isosceles. Now, what that then means is that, oh, here I forgot something. What's my reason here? Pythag. All right. Pythagoras. You can write Pythag. You will start seeing me using these reasons when we get into questions. Okay. AB is equal to AC. Okay. And we're going to write a reason for that. Guys, we're not going to use the word isosceles when we write our reasons. It therefore means angle B would be equal to angle C. Now, what's going to be our reason? I know from grade 7, 8, and 9, we were taught base angles are equal. We don't use that anymore. We are going to say these angles are equal because they are angles opposite equal sides. Can you see where I wrote my equal? And here we're going to say sides opposite equal angles. The sides are equal because the opposite angles are equal. The angles are equal because the opposite sides are equal. We're going to need that. Please take note of the reasons and let's learn them quickly. The sides opposite the equal angles are equal. So we say sides opposite equal what? Angles. And opposite angles equal what? Sides. All right. We're good. Please, I want to go back quickly. I think I left something. I'm not sure if I wrote the reason for the first one. Sum of interior angles. Okay, what's going to be my reason here, guys? Please take note. I want to keep writing all the reasons. Here, we can easily say sum of angles. Sum of angles in a triangle. Take note of all the reasons. That's what we're going to keep writing. So it's a statement and reason. Sum of angles in a triangle. Let me put a box on my reasons. And you can also highlight them. Or let me do this. If I put a box around the statement and the reason that we are going to be needing as we go along. Yes, that's the first one we spoke about. Second one we spoke about. So you may please highlight them in your notes. Just need to drag this C2. 1 second. Let me move this downwards a little bit. There we go. So that. Okay. C1 plus C2 equals to 180 angles on a straight line. You can just write STR line. Okay, so that would be another important one there. Angles on a straight line. Guys, you don't need to write the whole thing in English. So we use mathematical symbols and little abbreviations. Sum of angles. So we have 3 on this page. Take note of them. We have 3 on this page. Highlight them in your note or put a box with a different color. Here, what do we have? Pythagoras theorem. Pythagoras. So we write Pythagoras. Okay, here we have another one. The sides are equal because up. Okay, let me just drag this. So already in a few minutes we have actually written 6. Wow. So make sure your mind is in the lesson so that you get it once as we move on. The reasons are very, very important. There are marks allocated for that. Okay, so these are the little things that we are going to look at for now when it comes to triangles. The right angle triangle, the theorem of Pythagoras there, isosceles triangle. Please, we don't use the word isosceles. We talk about sides opposite equal angles and angles opposite equal sides. So we are done with T. I'm going to run quickly now. I hope that makes sense. All right. Oh, just before I get onto this, all right. I should let me look at this quickly before I go to these triangles. Let's look at X quickly. So TX, because these ones that we're looking at are not circles involved. So I'm going to look at the part of a circle shortly. Now we have X. When we say X, what are we really talking about? It's just 2 things here. Let's call this A, let's call this B, let's call this C, and let's call this D. What are we going to say? So every time I see an X in my circles and all, this is what I'm going to be thinking about. Angle A plus angle D. Can you see that's a straight line? Let's highlight it. Or angle A plus angle B, just moving around the circle. Angle A plus angle B. Or angle B plus angle C. Or angle D plus angle C. All of this are equal to 180 degrees and they have the same reason which we have looked at. Angles on a straight what? Line. Now, so that is number 1. Number 2. angle A would be equal to angle C. We did this in grade 8. Angle D would be equal to angle B. If you remember the reason, great. If you don't, that's what my job is. Vertically opposite what? Angles. And when you write, you can just simply write vert up angles. Vertically opposite angles. So we can write it as vert up angles. Just circle this one again for emphasis. Then number 3, angle A plus angle B plus angle C plus angle D. We know what that is. That is round that point there. It's 360 degrees. Angles around a point. Okay, another Euclidean statement and reason. This is the end of X. So we have looked at thanks. Triangles. When we see triangles, we know what to think about. When we see an X, this is what we think about as well. Vertically opposite angles, angles on a straight line, and angles around a point. Whichever one fits into the question that we are dealing with. All right, so these are basic things that we all know. So this first few minutes was just a reminder. Now we're going to go into circles. And before I get into circles, I'd like us to see the definitions of these terms. You'd see a circle here, all right? And I'm going to use a highlighter. That is the center of the circle there, okay? Now, with my highlighter, I'll be looking at all the points one by one. First is a tangent. Please check there. The tangent is a line touching the circle only at one point. Please take note. It only touches. It will not cut through the circle. It must just touch externally. That's a tangent. You'll be tempted to look at other things and say they are tangents. No, they are not. The one that cuts through the circle is called a secant. You need that knowledge. Although we're not going to be using the secant as a reason, but know the difference between a secant and a tangent. Now, a diameter is also important from one end to another. All right? And I'll be showing you the difference between these three. There are some things that are quite similar here. I'll be showing you the difference. Diameter. The issue is the diameter must pass through the center. Check. A line passing through the center of the circle. All right. It is double the length of the radius. I hope we know that. That is a radius and that is a radius. So 2r. So my D diameter is 2r. We can add that to the note. Radius is from the center. All right. A radius is from the center to the circumference, and we could have as many as possible from the center to the circumference. Now, look at that small space there. That small space between two radii, we call it radii, is called a sector. We're not going to need that word as a reason in our Euclidean journey for now. Okay, so let's move on. Now look at a chord. A chord. A chord is almost like a diameter. I want you to listen to the difference. So a line with end points on the circumference, can you see? Which is similar to a diameter. But what is the difference? This chord does not pass through the center. The diameter is a chord that passes through the center. That's the difference. So if it passes through the center, it is called a diameter. Otherwise, it is called a chord. And the chord, please, I'd like you to now listen to this point. The chord actually divides a circle into two. The chord divides a circle into 2. What do I mean? A diameter also does, all right? Okay, so we're going to have a chord there. That is a chord. Now, this chord divides the circle. If you look at this part, it is called a segment. All right? So please watch this, because I'm going to need this statement as we go on. Let me just make it a bit bigger. This is called the major segment because it's bigger, and this is called the minor segment. So we have a major segment and we have a minor what? Segment. I just want it to fit in. A minor segment. So a chord will divide a circle into 2, a major segment and a minor segment. Please don't forget that this is a chord. We're going to need that knowledge as we go on. Then we have an arc. Please watch this. This little section here, from here, now the arc is on the outside. So we have 2 arcs. This green one is called the minor arc, while the other part is called the major arc. So the chord does a lot of things. Tells us where the minor arc starts from and where it ends. So the minor arc is the circumference of the minor segment. The circumference of the minor segment. We need all of this knowledge as we go on. While the major arc is the circumference of the major segment. Now, we're done looking at the parts of a circle. We are then going to go into our first theorem based on how we have arranged ours. Remember, we said thanks to the doctors in Cape Town. We are now going to look at D. We are now going to look at D. What does the letter D stand for? So let's go. D. Okay, we're done with X, right? We did X. So this X is out of the way. 1 second. So this is a D. This is not X. I just need to change this quickly. This is a D. Good. Now, what does my D stand for? We're now into Euclidean. So in this lesson, I'm just going to look at, I'll stop on D, and then the other part I'll look at the rest. D. The word D is the first letter of the word diameter. When I see a diameter, what should I be thinking of? Remember, the diameter must pass through the center of the circle. Okay, there are certain words I'm going to now start using, and I'll tell you what it means. Okay, so that is a diameter. My dear learners, if I were to take a compass and do a construction for you, we would actually see this. All right. Time would not allow me to do that, but I can quickly just try since I want to end this first lesson here. Let's see if we can try to get that. I'm going to try to see, because I wanted to see that all these things that were not just, they were not made up. Okay, so I'm going to get a protractor, going to get a ruler here. Sweet. Okay, so watch this. I need to actually get the correct center of the circle. Okay, let's try. I need to take the circle away and get the center of the circle. Okay, might need to get a little compass. Awesome. Let's see quickly, because I want us to understand and enjoy this topic. It's very lovely. So we have a point. We're creating a point there. Okay, creating a point. Let me see if I can use this to just draw. Okay, so I'm creating that point. You don't have to do this. This is just me trying to be very accurate, because there is an investigation on this, but I won't be doing that. Okay, so why are we not drawing? I am supposed to be drawing. Okay. I need us to draw. Okay, hold on 1 second. Oh, all right, I see. I think I know why we're not drawing. I need to select that. Oh, there we go. There we go. I was holding it wrongly. Okay. Perfect. So we have a very perfect circle. Beautiful. Lovely. Okay, I've returned that to the owner. Now, I want you to watch this. So we are going to create a diameter passing through the center of the circle. We have that point. I'm going to move this a little bit because I want to get my straight line. Oh, okay, I got that part. Lovely. I got that part. So let me extend this line from here right through to that point. Great, perfect construction. So that is a diameter. My circle has been divided into two. Now, what are we saying here? If I take a ruler, okay, since my own lines are straight, and I take it to the circumference from that end and bring it here again. So I am actually creating an angle from the ends of a diameter. I want us to measure this angle. Okay, so how are we going to measure this angle? I'm going to put my compass there. All right, and I need to turn it. Okay, let's do that. And turn it around. If I do this, beautiful. Beautiful. Is it straight? Not yet. Sweet. So I'm showing you the construction on the first one. On the other theorems, you can try to do the construction as well, just to enjoy and understand, so that it's not just theory. I want to measure. Can you see we are reading? We're taking a measurement, reading there. Okay, if I put this directly at that point. All right, it needs to go in a bit more. There we go. Okay, let's align that line. All right, I'm getting 91, I think, because of the thickness of my lines. Okay, all right. So the construction actually tells us that that's a right angle. That is a right angle. And that's what it's supposed to look like. I should be getting, if I move it to the edge. All right, can you see if I move it to the exact edge? Let me show you that. Oh, so a diameter produces a 90 degrees on the circumference, and that's the theorem. Okay, so we can throw all of this away. Oh, beautiful. Let's call this A, let's call this B, and let's call this C. What is going to be my theorem? What is going to be my reason? And that, and I will be ending this first session here on a diameter. Please, you saw the construction there. It is very, very important that you are able to make that happen. All right, so we're looking at the diameter. Once you see a diameter, what are you thinking about? You're thinking about a right angle, what? Triangle. A right angle. Anytime. But here's the deal. Do not make an assumption they must tell you that it is a diameter or that it passes through the center. And this is what we are going to be saying now when it comes to a diameter. A diameter divides a circle into two, right? So this one is called a semicircle. All right? So we are going to be saying angle in a semicircle. Angle C is equal to 90 degrees. Angle C is equal to what? 90 degrees. Angle in a semicircle. Angle C is equal to 90 degrees. Angle in a semicircle. The word semicircle comes from a diameter. And we are done with this. That's the first thing. Number two, we can therefore conclude that ABC, triangle ABC, is a right angle triangle. Oh, which means I can be using the theorem of what? Pythagoras. And it is good to see how math is connected. I can also use SOHCAHTOA. Trigonometry comes in again. Those are the two important things that I need to know. For Pythagoras, AB becomes the hypotenuse. So AB squared equals to AC squared plus BC squared. And the reason will be Pythagoras. And we can also bring in SOHCAHTOA. All right, so this is the first thing I'm going to be looking at, and I'll be looking at the next 3 or 4 in my next session. But when you see a diameter, these are the two things you are thinking about. Angle C is 90 degrees, sum of angles in a triangle. And number 2, it forms a right angle triangle. And that tells me that I can use the theorem of Pythagoras, and I can also use SOHCAHTOA. Let's see. I've got just 2 questions. Also here. Oh, look at that. Can you see? Just by without any words, we can see PR. PR is a diameter. What is X? Already, by looking at that, I see that Q is 90. So I can start by saying angle Q equals to what? 90 degrees. What's my reason for saying that? Angle in a semicircle. Or we can also write the reason. Oh, I forgot. We can also write it like this. Angles in a semicircle. Half a circle. Half a circle. It's also allowed. Okay. Now, if that's the case, what is X therefore? Because we're looking for X. We know that 55 plus 90, so we just need to get a calculator quickly and say 90 minus 55. Remember, 55 plus X would give us 90. We spoke about that. So, what is X? X is 35 degrees. I hope you understand how I got my X. By saying 90 minus 55. And what will be your reason? Sum of angles in a triangle. We are done. Statement and reason. So please draw that circle quickly and make your notes, whichever note you feel you need to make. I'm looking at B now. Oh, again, I see AC as a diameter. Oh, therefore, angle B is equal. You need to write this all the time. 90 degrees. Angles in a semicircle. Oh, beautiful. And you can also, to make things clear, put that 90 there. So 52 plus X. Oh, sweet. So what is X? X would be 90 minus 52. Here there's no reason because we just know we already said it's 90. And what is your answer? Your answer will be 28. Am I right? 38. 38 degrees. And we are done. Angle in a semicircle. So once you see a diameter, please remember the two things that we spoke about. Remember the two things that we spoke about. All right, we're going to look at quite a few more activities. Just need to finish my notes on that. But let me see. Okay, now I'm going to stop here. And in our next session, I will be looking at the rest of the theorems. But not at a go. We'll break it down. So what did we look at today in this first lesson? We looked at T, X, and D. So in our next lesson, I'll be looking at R, S, and C. Then we look at P, T, and 1. So 3 lessons, and the fourth one will be activities. T, X, D. T, triangles. X, vertically opposite, and D, diameter. I hope it makes sense. You can always pause the video, rewind. Please watch it again. Get this concept sorted before we get into the next concept. This is Crazy Physics signing out. I hope you enjoyed that short session, and I'll see you in our next lesson where we'll look at the next 3 with their proofs. I'll see you and catch you. Goodbye.